Okay, ladies and gentlemen, we're looking at rational expressions. And a rational expression is just a fraction where the numerator or the denominator is a polynomial. We've got some examples here. 6 over x minus 1, z squared minus 1 over z squared plus 5, m to the fourth plus 18m plus 1 over m squared minus m minus 6, 4x squared plus 6x minus 10 over 1. I don't have to write the 1 on the bottom of this one. That could just be 4x squared plus 6x minus 10. That would just be a polynomial. But since I wrote it as a fraction, that means it's a rational expression with how I've written it. A rational equation is a type of equation where it involves at least one rational expression, fancy name for a fraction. Identity equation, those are equations that are true no matter what value is plugged in for the variable. If you simplify an identity equation, you'll always get a true statement. That means the left side will look exactly like the right side. To solve rational equations, we identify the LCD, or least common denominator. We identify what makes the LCD equal to 0. These are going to be excluded values. That means if one of those numbers pops up as our answer, we have to throw it out because it gives us a undetermined form because we can't divide by 0. We multiply every numerator by the LCD. We cancel common factors, and then we solve for x. What does that look like? Well, let's look at a couple examples of it. Okay, so an example, we've got solve x minus 1 equals x squared minus 4x plus 3 all over x plus 2 for x. First part is write both sides as a fraction. That x minus 1 on the left of the equal sign isn't a fraction, so I need to put it over 1. The right's already a fraction, so we're good there. Second is identify the LCD, or least common denominator. Well, the denominator on the left side is 1. On the right is x plus 2. I need one of each denominator, one of each factor of each denominator. So that's just 1 times x plus 2. So the common denominator is just x plus 2. Identify the excluded values. That means whatever makes this equal to 0. Well, that would be a negative 2. So x can't be negative 2 because that would make this side dividing by 0. Now for the fun part, multiply both numerators by the LCD. So we take the left side times x plus 2 and the right side times x plus 2. And here's the beautiful part about multiplying by the LCD. We now get to cancel the common factors. We don't have any common factors over here, so that doesn't help, but right here, x plus 2 and x plus 2 cancel, and we now don't have any fractions. We just have x plus 2 times x minus 1 over 1, so that's just x plus 2 times x minus 1. And over here, we just have x squared minus 4x plus 3. And on the left, x plus 2 times x minus 1 multiplies out to be, let's see, x times x is x squared. X times minus 1 is negative 1x. 2 times x is 2x. 2x minus 1x is 1x. 2 times negative 1 is negative 2. And now we're ready to solve for x. So I'm going to subtract x squared from both sides. I'm going to add 4x to both sides and add 2 to both sides. The x squareds cancel. I'm going to have 5x here. The 2's cancel. The x squareds and the x's cancel on the right. I'm going to have 5 on the right. Divide both sides by 5, and I've got x equals 1. That's not an excluded value, so if I plug it back in, I will get a true statement. And in this case, we can see plugging it in here, 1 minus 1 is 0. So that means if I plug in 1 over here, I should get 0 on top. Second example, we've got excuse me, fractions on both sides, so that's okay. We don't have to do anything there. So we just need to immediately jump into finding the LCD. So on the left, we got 4 minus x. On the right, we got 4 plus x. Those are both different, so I need one of each of them. So our common denominator is 4 minus x times 4 plus x. And then our excluded values would be positive 4 for this one and negative 4 for the other one. Multiply both numerators by the LCD. So on the left, we got 4 minus x times 4 plus x times 4 over 4 minus x. On the right, we got 5 times 4 minus x times 4 plus x times 4 plus x, all over 4 plus x. And then we cancel our common denominators. Notice we got a 4 minus x and a 4 minus x. We got a 4 plus x and a 4 plus x. They're going to cancel. And so we have just on this left, 4 times 4 is 16, x times 4 is 4x. On the right, 5 times 4 is 20. 5 times negative x is negative 5x. So we cancel those common factors. We don't have fractions anymore. Now I can solve for x. So I'm going to add 5x to both sides. Because that'll cancel over here. Subtract 16 from both sides. So 4x plus 5x is 9x. 20 minus 16 is 4. Divide both sides by 9. We get x is 4/9. That's not the excluded value, so if I plug in 4/9 for the x in the original, left side should equal the right side. Next one, a little bit more complicated, but both sides are fractions, so we're okay there. Figure out the common denominator. So I just put parentheses on the left for both of those. On the right, x squared minus 4 factors into x minus 2 times x plus 2. So x minus 2, and this has an x minus 2, so I definitely need one of those. This has an x plus 2. This has an x plus 2. So right here is my common denominator, x minus 2 and x plus 2. I just need one of each of the factors. The excluded values, well, can't be 2, can't be negative 2. Now I multiply both numerators by the LCD. That gets kind of long. So x minus 2x plus 2 times x plus 5 over x minus 2. Plus here I changed it to a plus and a negative 5 because we're adding the opposite. Got x minus 2 and x plus 2 on top and x plus 2 on the bottom. On the right, x minus 2 times x plus 2 times 28 over x minus 2 times x plus 2. Now we can start canceling those common factors. On the first one, the x minus 2's cancel. On the next one, the x plus 2's cancel. On the right side of the equal sign, x minus 2 and x plus 2 both cancel. So now I've got x plus 2 times x plus 5 plus x minus 2 times negative 5 equals 28. All the fractions are gone. Now I need to start multiplying. This just simplifies to, let's see, x times x is x squared. X times 5 is 5x, 2 times x is 2x. I can combine those to 7x. 2 times 5 is 10. X times negative 5 is negative 5x. Negative 2 times negative 5 is positive 10. And now I can kind of combine those. I got an x squared. I got 7x minus 5x. That's going to be 2x. 10 plus 10 is 20. Now move the 28 to the other side because I can't just solve for x. I've got a quadratic. With those, we got to get it set equal to 0. So now I've got x squared plus 2x minus 8 equals 0. Solve for x. That left-hand side factors into, let's see, to get negative 8, 4 and 2 make 8. And if I make it a negative 2, 4 plus negative 2 is positive 2. That works. And what makes each of those 0? Well, negative 4 and positive 2. But that positive 2 is an excluded value, so our answer is just x equals negative 4. It's the only number that'll work. Okay. Now use that to help you on practice 1 and practice 2. Practice 1, you're working through all of them, and one of them might look familiar, just changed a little bit. Practice 2, Kieran's done the work, but he messed up someplace. You got to figure out where he made the error and find the correct answers. Excuse me. Example 4 is working with identify if it's an identity. Well, that kind of means we need to take this left-hand side and simplify it. So x plus 2 to the third means I need to do x plus 2 times x plus 2. So I got x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4. Then I need to multiply that times x plus 2. So we get x cubed, 4x squared, 4x, 2x, 8x, and 8. Combine all those, we get x to the third plus 6x squared plus 12x plus 8. That does not equal x to the third plus 8. That means this is not an identity because the left side does not look exactly like the right side when you simplify. Next one, x squared minus 1 times x to the fourth plus x squared plus 1. So I need to multiply that left-hand side out. So I put x squared minus 1 down the front and x to the fourth plus x squared plus 1 across the top. We get x to the sixth plus, and then we'll have an x to the fourth and then x squared for the top row. And then negative 1x to the fourth, negative x squared, and negative 1. I've got an x to the sixth, the x to the fourth and x to the fourth cancel, the x squared and the x squared cancel, so we are left with just x to the sixth minus 1. And so the left side does equal the right side. This is an identity. And so on this practice 3, I'm just asking you, are they identities? You're just going to circle yes or no. Got to simplify one or the other sides. Like this one, you got to simplify the left and you got to simplify the right. On B, you got to simplify the right. On C, you have to simplify the left, and on D, you have to simplify the left. Example 5, we want to know what the points of intersection between the graphs of these two functions happen to be. So we set the equations equal to each other. So x squared times x plus 1 equals x plus 1. And then I have to simplify and get set equal to 0. So that means I have to multiply this out. That's going to get x to the third plus x squared. On the right, I still got x plus 1. Now I'm going to subtract the x and subtract the 1 to the other side. And generally speaking, with a polynomial like this, we need to factor. So we're going to factor by grouping. So I'm just going back to this step where I was taking that x plus 1 and separating it, or moving it to the other side. So it's kind of, these first two both have an x squared. That's why I pulled it out. And we're left with x plus 1. And if I look at negative x minus 1, if I pull out a negative 1, that's going to leave x plus 1. So here I've got x plus 1 in the first term and x plus 1 in the second term, so I can pull that out. So I got x plus 1 times x squared minus 1. That x squared minus 1 factors into x minus 1 times x plus 1. So this first factor and the last factor are the same. Negative 1 makes both of those 0. For the middle one, it's 1. So right now, I think the zeros are negative 1 and 1. I think those are the two x values that will make the y values same on these particular functions. So I got to plug them in and check it out. So g of negative 1 is 0. G of 1 is 2. So I just plugged them into the easy one. Negative 1 plus 1 is 0. 1 plus 1 is 2. Now check the f. See, negative 1 squared is 1. Negative 1 plus 1 is 0. 1 times 0 is 0, so it matches. Plug in 1. 1 squared is 1. 1 plus 1 is 2. 1 times 2 is 2. It works. So our two ordered pairs are going to be negative 1, 0 and 1, 2. That's where those two functions would intersect on the graph. I'm asking you to do the exact same thing with practice 4, where our f of x and g of x equal, but I give you 6 ordered pairs. I'll tell you more than one of them is going to be a yes. So you're just going to either write yes or no for each of the ordered pairs. Remember, it's got to make both equations true. So example 6, last one that we've got on here. This is working with being able to rewrite formulas. And so there are many cylinders with a volume of 144 pi cubic inches. The formula for the volume V in cubic inches of these cylinders is V equals pi r squared h. So it's the area of the base times the height, because the base is a circle. And the equation of the surface area in square inches is 2 pi r squared, so that's twice the area of a circle, that's the top and bottom, plus 2 pi rh, that's just the lateral sides. So we want to find h in terms of r. So I need a formula that's got h and r in it and no other variables. So I look at this volume formula and I'm told the volume, so I can replace v with 144 pi. And then I've got equals pi r squared h. Now I want to get h by itself and I don't see any pluses or minuses, so that means we're multiplying by pi r squared. Time to do that, we divide. So we get 144 pi over pi r squared. And just h on the right. The pi's cancel, so we have 144 over r squared equals h. Now we want to write the surface area function in terms of just r. So I come to the formula, and instead of h, that's the only problem I've got, I got to replace h with what we just solved for. So that's going to be 144 over r squared. And I could kind of simplify that. Let's see, I can't do anything with the 2 pi r squared, but over here I can take 2 times 144, which is 288, and times pi, and then I can get rid of the r, 1 r top and bottom. So we would have 2 pi r squared plus 288 pi over r. And notice that's kind of a rational expression. That's why we've got that in this particular setup, this set of notes. And so the last part is you practicing that with something very similar. And then you'll turn in your practice checkpoint to me to check.